I am very stupid. Yeah. Yeah, I'll say it. I was on vacation, and I was looking through some of the old comments, and I remembered one about copper bulbs. And I remember just how confused I was by the whole comment. It was basically saying um, that why didn't I just use copper bulbs for saving? Because aren't they perfect? And I kind of just ignored it because I assumed that, well, I assumed that I was doing it right, and I just didn't understand what they're talking about. But as it turns out, that was a smarter person than I. Because I was watching a Mumbo Jumbo video later, and I saw him making a display, and he was doing it using copper bulbs. And I noticed that you can just toggle copper bulbs on and off. You can just turn them on and off easily without needing to do any extra work. That's just how they work. And from that comment, I realized that I need to redesign the entire storage system. And then I started thinking more. And I started thinking about how my display works, okay? My little display over here. And I realized that the way that I set it up is also completely stupid. And very silly and unnecessary. So, the conclusion of all of this is, I'm starting over. I'm completely scrapping this and making an entire new computer. Because this, Joe, he did his best, okay? But we did not design him the way that we should have, and so we're starting over. But that gives me a chance to also rework everything that I've done so far. For example, those beautiful thumbnails that you've seen, guess what? I didn't make those. Those are one of my friends, but he just moved away for a little while. So I will not be making any more good thumbnails. I'll do the normal stuff, but don't expect any more high quality thumbnails from me, because those are just not fun to make. I had to make the most recent one, and it took so long, and the thumbnail's so bad. So I'm never doing that again. But yeah, so now we need to restart the entire thing. But I'm okay with that because it gives me a chance to start over. There are really 3 reasons why I decided to start over, but one of that one's kind of more nerdy. It has to do with assembly, which I learned about. It's the language that computers speak, and I did a whole bunch about it during this, and it's given me a whole idea of how to redesign the input system. And so basically, we're restarting. But I'm not going to talk about that in this video, probably. Maybe I will. Nah, that'll be a later video. Today, though, we are going to be talking about how we're going to redesign our storage system, and maybe also the display, because I want to get back cracking so we can get back to where we were before, and really do this. I don't know if you guys can tell, but I have been itching to get back to doing this. Like, when I realized that I could make this entire thing so much smaller, I have been dying to come back and make more content. But, yeah, let's get started. So here are the elusive things which apparently will completely revolutionize my system. And I said that kind of condescendingly. They will genuinely revolutionize everything. So, let's get started here. So, from what I understand, how these work is you click it once, and it stays on. Then you click it again, and it remains off. Okay, that's really good. For anyone wondering why that's cool, this is the system that we used to accomplish that same thing before copper bulbs. So we've just made our system already way smaller. Okay, so let's see how this works. So can we take a comparator output? We can. Is there just an actual... Okay, there's no actual output, but we can do this, which is roughly what I thought we could do. Yes, okay, this is really good. Before I continue, I want to just briefly explain what we need, in case you're confused by that. Basically, we need something that we can turn on, and it will stay on, and this on state, okay, is some amount of data saved because of locked repeaters. So, you can kind of see here, when we have this repeater running into the side of this one is locked, and this allows us to stop the flow of data. You can see this is not affecting the redstone lamp, but if I got rid of this, it would affect the redstone lamp. So essentially, we want a way of doing what you just saw there, where we can save some data, which is in our storage. So I'm just going to start doing stuff. I have a general idea for how I would want to do this, and it involves a lot of this concept, where so we have this thing set to on. Maybe we just leave it like that, actually, and then it's set to on. We have an observer, and that observer just reads the input from a button. And what that would do is that would flash it off, and then flash it back on again. And while it's off, that can allow data to come in. Okay, so that allows the data to come in, and then it flashes again, relocking it. God, that is amazing. Now, the other idea that I had involving this is that I want... How do I preface this? So, we created this system a while ago of keys right here, okay? Which essentially, we use these three levers to determine what data goes on. They are keys to which block of data is the output. If that makes any sense, which probably not. It's a little confusing, but essentially we have these keys, and I just realized that these are the keys. But yeah, so we have these keys which decide what data goes out. And the system for making those keys is very complicated. It's down here. I have a whole video about it. It's the one called data extraction, I think. But we have this system, and what I realized is that this system can also help us determine which we want to save or unsave, which piece of data. And it should pretty much be as simple as this. So we have one input into our AND gate, which is the key. It's saying this is the one that we're choosing, so there's that. And then we just have the button, the save button, over here. And that would edit our data. That would allow it to change. That's really cool. Okay, that is amazing. That changes so much. This is gonna take a little bit of reworking, but we can make that entire system way smaller with way more modules. Now, what we're gonna do is we're gonna build up a very simple prototype for the same system of storage that we've been using since the very beginning, which is just a input here leading out into some options for storage. This will make more sense in a second. Hopefully now you can kind of start to see what's happening. So we have this data here, okay? Which when we flick it, it just makes copies of it, right? And it's only when we click this, when we successfully save with this button, that it will lock one of them. It will save at that point. When that point, where it is determined here. Now, for example, let's say we have this one. We specify that we want to save here, okay? If we arm the system first, that is. Hold on. So now the system is primed. If we store 1, 0, we want to store that, and we click save, then it will save there, and then it'll let it in. You can kind of see it there. It let in the charge, and then it locked it again. And now you can see that we can affect these a bunch. We can affect our input, but it does not affect this one. This is editing me. I had a different idea, and yeah, you're gonna see the aftermath of that, but basically it was really bad, so we didn't end up doing it. What it was a concept for how to make these keys, like how to specify which of these we're using, how to specify which of these we use, and it was a whole thing, and it was very big and ugly and just bad, so we didn't end up using that. After further consideration, I have decided that idea kinda sucks. And like, yeah, it's just way bigger than it needs to be. So we're gonna go back to the old design of which is what I have here, which is basically just we check that this one and this one are not on. And since that's true, boom. Then down here, we're going to try to use something that I've seen other people doing, which is making just the speed of their farm. What am I talking about? Making the redstone signals a little bit faster by utilizing these weird little methods of not using repeaters, because repeaters do delay. They do delay things a fair bit, which is a problem because, you know, this is gonna be pretty big. So we're gonna try some of that, incorporating a little bit of it, and then we're just gonna build up the system again. We're just gonna need to use repeaters. This is way too bulky. So now we're gonna check if this one is on and this one is off, which I have a little weird solution here for. We're gonna do that, then leave that one alone. And that will allow us to not make anything more complicated than it needs to be. So we can just run that out like this, I think. No, because we need to check if this one is on and this one is not on. Yeah. Except then we also need to knot it here. This is a little more confusing than I thought it was going to be. If you're confused about that last clip, basically this is our design for the AND gate. And so basically we just have our inputs here and here, and then they run out and affect this redstone torch. But because of the positioning of the wiring and everything, I'm having it so that instead we do this, which accomplishes the exact same thing. It just looks a little bit uglier. But yeah, that should work now. So if we flick this one, then you can see that one turns on. Now, something we need to remember is that when we use a redstone torch in this line, we need to then use it after to make sure that we don't change what the input is. Because currently the input up here on this line is off. But if we didn't change it again here, it would become on because of this NOT gate. So let's just move along the charge here. Because there was no redstone torch involved, we are going to need to use a repeater here. We're going to need to use a repeater anyway, because we need to hard power these blocks. That's a little annoying, but it's okay. Wait a minute. What? Okay. You know what? I don't really get it, but everything's good. You think you know how redstone works, and something like that happens. Now this one works. I really need to work out how to use the /clone command, because this is getting a little embarrassing. Hold on. At least we get to do this. I don't have to blow anything else up. Woohoo! Yay! And that one's gone, and then we just get to break the rest. I watched a lot of Minecraft YouTube over the course of my vacation, which I get is incredibly lame, but it really just made me want to play survival Minecraft again, because I have not played vanilla survival in a while, and it honestly just seems like a really good time. And so I'm kind of fuck. Finally, oh my gosh. As I was saying, it's made me really want to play survival Minecraft again. And maybe I'd make that into a series. I don't really know if that's something that would fit with my content at all. But, I mean, I'd like to do it, you know. If you, you know. Maybe, I don't know, I'll consider it. I'll consider it. But, regardless, ignoring that fact, we have pretty much got our system all created here. We just need to make this AND gate super quickly, and like that, and like that, and we have our full key system. No, we don't. What's wrong? What? Huh? Huh? Oh. What? Okay, so I think we have to flip this one. What on earth is going on here? No. We need to flip this one to being on, and then put a repeater here. Great. So that is our better key-based system. All we have to do is prime it by flicking all of these on. Now our system is all primed, and we can do it. So if we want to save 1, 1 at the third spot right there, then we click this button, and it saves it. Now let's say we want to save 0, 1 at the first spot right here. Then we just click save, and it goes there. Now the best part about this system is that we can very easily use this as also a deleter. We can delete things with this by just flicking it to 0, selecting which one we want to delete, in this case the first one, this one, and we can erase it with the same button. I know, it's really amazing. Now that is our updated and all fixed storage system, which means that, I mean, yeah, it's pretty much ready to be implemented. We have everything exactly as I want it to be. It's very compact, very small, and I'm pretty sure that it is able to be routed out. Let me just check that. We can take the data out successfully without running into any problems. Good. So yeah, we have our storage system done. But yeah, that's definitely all that I have time to make today. You can see me starting on part 2 over there, but this is more than long enough for one episode. So yeah, thank you very much for watching. I hope you have a good day. Bye-bye.